Okay, gang. So our last section in chapter 6 is going to be applications of everything we've done in the first 4 sections. So we've been talking about exponential functions, logarithmic functions. We talked about their characteristics, their graphs. We solved the equations, exponential equations. We solved logarithmic equations. And now we want to see if we can put those things to good use in real world situations. Probably the first example of an exponential function in an application that you've ever seen before is this one right here behind me, compound interest. You probably would have done this probably in your Algebra 2 class, okay? Gang, this is an exponential function, and here's why. First of all, it's called the compound interest formula, okay? It will tell you the amount of money that you're going to have in an account after a certain number of years. Usually T is equal to time. If you invest a principal amount, so P is equal to the amount of money you walk into the bank with and say, I want to invest this much, like $500 or something. R is the interest rate, usually given as a percent, but when you use the formula over here, you got to make sure you put it in the form of a decimal, right? Where it's a calculator thing. N is the number of times that interest is compounded in a year, okay? The only clue that this is even an exponential function to begin with is the fact that you've got the variable time in the exponent. Everything else in here is fixed. Well, except for this, of course, right? As time goes on, the amount over here is going to change. But otherwise, on the right-hand side, the variable t, that's what makes this whole thing an exponential function, okay? Now, there are other applications to be sure. In the second presentation, I'll show you an exponential growth and decay. But just for the moment, let's see if we can remember this. Okay, let's say you walk into the bank with $500, okay? Okay, that's your principal or your initial amount. Okay, the principal or the initial amount, how much you start off with. The interest rate, let's say, is 0.0165. In other words, 1.65%. Okay, pretty small. The number of times interest is going to be compounded in a year, let's say quarterly, so 4 times. Okay, so n is equal to 4 times. And let's say you want to know how much is going to be in the account after 6 years. So t will equal 6. Okay, so what you do is you take all these values over here, you force them into the function, grab your calculator, and determine how much money is going to be in the account after 4 or 6 years in this case. So here's what it looks like. Okay? And whatever that is with your calculator, right? Because we were just kind of doing this off the cuff. So figure this with your calculator. That'll tell you how much you're going to have in the bank, in your account, rather, excuse me, after 6 years. And of course, now if all of these things change, stay the same, rather, stay the same. And all you want to do is just change the time. Like maybe you want to know, well, all right, let me leave it in there a little bit longer. How much is it going to be after 10 years? You know, something like that. Or you might want to know, how long is it going to take for you to double your money? Right now, there you don't know what the time is. That would be something that you want to figure out on your own. There are problems like that in the homework, to be sure. So we'll try some of those. And I think what we'll do again is we'll do those as pen casts because they move a little bit faster. Okay. But otherwise, in the next presentation, we'll discuss another kind of application called exponential growth and decay.